We're back again with another triangle. Today, let's say we are given side A, side B, and side C. So here we have side, side, side. And then let's say we're trying to find the area of the triangle. Well, once upon a time, we figured out that we could get the area by this formula. And this required side, angle, side to use. But we don't have an angle. But we can find the angle now by using the law of cosines, because the law of cosines helps in the side, side, side case. So we write law of cosines. And since I have sine of A up there, I want to find angle A. So I'm going to use the version of the law of cosines that lets me write down cosine of angle A. And my goal is to solve to get angle A so I can put it up in there. All right. Let's move the b squared and c squared over. And let's divide by the negative 2bc that's multiplied on the cosine. And now we have this. We can plug in the numbers. So I'm going to put the cosine on the left of the equation, equals A is 9, B is 12, and C is 19. And if we plug this into a calculator, we get a number like that. Now, the way we discussed this before was we said, all right, so cosine is the x-coordinate in the unit circle, and I need it to be 0.9298. Now, there are two angles within one lap of the unit circle where that happens, but this angle is more than 180 degrees, so it cannot happen in a triangle. So the angle that I'm really interested in is this one, this angle A, which is simply cosine inverse of that number we just got. So we know that angle A, if we type this into a calculator, gives us 21.59 degrees. So that, right in here, is 21.59 degrees. And now we have side, angle, side. We can happily do that by saying the area is 1/2 times B, which is 12, and then C, which is 19, and then sine of that angle we just found, 21.95 degrees. And since we're rounded there, we'll say approximately equal there. And we can take that, punch into a calculator, and we get 41.95 as the area. All right, we did it. Side, side, side. Use the law of cosines, use the side, angle, side formula, got the area. So what we just did was we said we have a triangle with side, side, side. And that doesn't let us find the area using this formula until we get one angle. So we use the law of cosines with side, side, side to get an angle, and then plug the angle in here to get the area. Now, there's nothing wrong with doing that exactly every time. But if we're doing the same thing every time, we might as well come up with a formula that will do it in fewer steps. So, my goal is to combine these two equations so there's no angle and only sides. I have an idea. I'm going to take a squared minus b squared minus c squared all over negative 2bc is equal to cosine of A. And I'm going to say cosine of A and sine of A are related by cosine squared plus sine squared equals 1. Okay, so I'm going to square both of this, which means this is a squared minus b squared minus c squared all squared over 4b squared c squared is equal to cosine squared of A. But I also remember that I need a sine squared here, so I'm going to go area squared is equal square of 1/2 square of b square of c, and then sine squared of A. But since sine squared is 1 minus cosine squared, I'm going to take 1 minus all of this right here. We did it. So that is a formula that has nothing but sides in it. And if I plug in A and B and C, I'm going to get the area. There's nothing wrong with leaving it like that, but we can clean it up a little bit. So let's take this b squared c squared and distribute it there and there. So what will happen is I will have 1/4 b squared c squared minus, this is going to give us this, okay? And I want to combine with a common denominator, so I think to myself, what if I put a 4 here and a 4 here, and then factor out the 4 from the denominator? So I should have 1/16. And then I look at this and I look at this, and I say, well, this is actually 2bc in parentheses squared. Which then I think about as the difference of squares. So I can write this like that. And I'm going to go minus. What have I just done? I've said this squared minus that squared. I think of this as like x and y. We'll factor out and make x plus y and then x minus y. So what I said is if I take 2bc plus all of the stuff in here, I get this. And if I take 2bc minus all the stuff in here, the negative distributes, so I get negative a squared plus b squared plus c squared. Okay? Then we say, hold on, there is a way for me to take just these 3 terms and factor them. There's a way for me to take just these 3 terms and factor them. And this is what it's going to look like. Now, what have I done here? So I took these 3 and turned it into this. Why can I do that? Because if I were to expand this, it would look like b squared minus 2bc plus c squared. And notice the negative in front makes it so I have negative b squared plus 2bc minus c squared. Cool? That's the justification there. Then over here I said this plus this plus this is going to turn into that, because if I expand this out I get b squared plus 2bc plus c squared. And I have the minus a squared there. All right? So why have I done this? Because once again, I have a difference of squares, which means I can factor again to make a plus b minus c, then a minus all of this, which makes the negative distribute, like that, and then here I have b plus c minus a, and then finally I have b plus c plus a. And this next step is a pattern recognition step. We say, well, hold on. This looks like I have an a plus b plus c, and all the rest of these are that except with one sign switched. Okay, so this can be rewritten as, this is a plus b plus c, take away 2c. This is a plus b plus c, take away 2b. And then this is a plus b plus c, take away 2a. And finally, this is just a plus b plus c. And then, if we take this 16 and say, that's 2 times 2 times 2 times 2, I can take this and say, this divided by 2, that divided by 2. This divided by 2, that divided by 2, and so on, and so on, right? I've divided each of these parentheses terms by 2. And so finally, the pattern looks like this. We know that this is equal to the area squared, so we're going to square root this at the end. And I'm going to define a specific thing. I'm going to define the letter s as a plus b plus c all over 2. This is what we call the semi-perimeter. So I've taken the perimeter a plus b plus c, divided by 2 to get half of it. And notice I see that 1, 2, 3, 4 times. So I will say the area is the square root of, and I'm going to put them in a specific order. I'm going to start here and count backwards. So it's the default case, just S. And I have S minus A, S minus B, S minus C. So it looks like this. And this is the formula for finding the area of a triangle using just the three sides. And perhaps you will believe that this is slightly prettier than that. It might be a matter of opinion. But this is what we call Heron's formula. Thank you, Heron. Well, now we have a formula, we might as well use it, though you may argue that applying a formula to numbers is the least interesting part of mathematics. We'll come back to the original example. Let's say we were given A is 9, B is 12, and C is 19. Okay. We want to find the area. So let's go ahead and apply Heron's formula. We're going to start by saying we need S to be A plus B plus C all over 2. So we're going to say this is A is 9, B is 12, and C is 19. We're going to take this and divide by 2. So the top should come out to be 40. So if I divide by 2, I'll get S is equal to 20. Great. Now, from here, what I'm going to say is the area is equal to the square root of S times S minus A times S minus B times S minus C. So if I put in the numbers I have, I would say, well, S right here is just 20. Multiplied by 20 minus 9 becomes 11. And then 20 minus 12 becomes 8. And then finally, 20 minus 19 becomes 1. And if I plug this into a calculator, what do I get? I should get 41.95. And we can turn this into an approximate sign. This is the exact same answer we got when we did this problem using the SAS formula, which it should, because that is the area of the triangle. So there we have it. This formula works all the time. When you have three sides, you can do it this way, or you can do the law of cosines and do the side angle side formula. Thanks, have fun.